Hello, Nakabugo. Okay, um, today I'm going to talk to you about angles. Um, an angle is created when two segments, or two rays, or two lines intersect at something called a vertex, or a combination of those. So, to go over what is a line is just a straight line that goes infinitely far in both directions. It keeps going that way, sorry for the mess, that way in infinite direction. Like all the way out of this room, out of the way out into the city, all of the way out into space and beyond. It keeps going. And this line keeps going the other way in the opposite direction too. So a line, you can see what its direction is, and it keeps going both ways in both directions for infinity. It never ends. As a ray is different. A ray, for example, starts at this point here in this room on this piece of paper, and it keeps going that way, and it never stops. It keeps going through those buildings, it keeps going through the hills, it keeps going into the sky and out into outer space, and it never ends. That is a ray. A line segment is different than a line and a ray. A line segment is when you have 2 points and you draw a line between those 2 points. The line starts over here and it ends over here. A line is infinitely long because it goes and never stops in both directions. It's infinitely long over there, out that way. This line is infinitely long back that way. You cannot measure this. The measurement is unending. It never stops. Even a ray, even though it's only half of the size, you cannot measure a ray, because even though you know the place where it starts, you can never find the place where it finishes. A line segment is different. We can measure this length with a ruler. We can say, okay, this is approximately 3 inches long, give or take about 0.1 inches. That was just lucky. I don't know how I did that. But this is a line segment. This is a ray, and this is a line. Now it's possible to draw points on the line so that this is a line segment, but the rest of this part is just the line. So from here to here, that might be a line segment. Or if we draw another point here on the line, this is another line segment. Or we could say, hey, from this point all the way to this point, that's another line segment. Sorry, I'm not a very good artist with one hand, or even with both hands. But my point is that a line segment, we can measure whether it's from this point to this point, about 2.5 inches, or from the first point to the middle point, about 1.5 inches, or from the middle point to the final point, from the second point, if this is point 1, point 2, point number 3, from point number 2 to point number 3, that's about 1 inch. line segments can be measured. Now, when a ray or a line segment, whenever they intersect, they create angles. Let's start a new page. I know we haven't even talked about angles yet in this video, and that's what the whole video is about, but I wanted you to understand lines, rays, and line segments first. Okay, here is a line. I'm trying to draw a nice straight line so that we can look at our angle. And you know what? We said it's a line, so let's draw little arrows on it to say that this line goes infinitely far that way, all the way that way. And this line never ends. It keeps going that way through the refrigerator and beyond. This line never stops. Now, let's draw a line segment. And this line segment has one point on our first line and another point right here. Sorry, I'm trying my best with one hand. Okay. This is our line segment. From point 1, which is on both the segment and the line, to point number 2. That's the line segment. There is an angle created by the intersection of the line segment and the line. Here is an angle. And you might say, hey Micah, there's not just the first angle. We'll call this angle A. Angle A. There's another angle right here. We'll call that angle B. So I'm going to do my best to draw angle A and angle B separately from each other, but still having the same measurement in degrees. I'll talk about what degrees are in a minute. Okay, so this is pretty much what angle B looks like if we just took angle B and brought it down here. There's angle B. Here's pretty much, oh my goodness, sorry, pretty much what angle A looks like if we took it from over here and brought it down here. This is approximately angle A. Now we've talked a little bit, I haven't personally talked to you, but the book has talked to you already about different types of angles, where there's acute angles, right angles, obtuse angles, straight angles, and reflex angles. Angle A is an acute angle. It's acute because it has a measurement less than 90 degrees. So, what are degrees? Degrees are defined as one full revolution, a full circle, having 360 degrees. If we cut the circle in half, then here's 180 degrees going around the circle, and here's another 180 degrees going around the circle. If we cut the circle in half again, that way there are 4 different parts to the circle, then we had originally 360 degrees all around, then we cut it in half, so it's 180. We cut it in half again so that this angle has exactly 90 degrees. Now, if you went and measured this, I drew it very poorly, I'm sure it wouldn't have exactly 90 degrees. But if you had a perfect circle here on the page, you cut it in half and you cut it in half again so that there were fourths, 4 pieces of the circle, all equal, then each piece would have exactly 90 degrees. 90 degrees. 90 degrees. 90. Now check this out. You can identify really clearly with just a piece of paper if it's a true standard piece of paper, like this receipt from Starbucks. You can verify that's 90 degrees. This is 90 degrees. This angle here is 90 degrees. And so is this one, 90 degrees. So 90 plus 90 plus 90 plus 90, going all the way and around in a circle, adds to be a total of 360 degrees. That's why there are 360 degrees in a circle. You might have heard of skateboarders doing a cool trick, like, oh man, I just did a 360 in the air. And that's when a skateboarder, they jump in the air and they spin around and do a full turn of 360 degrees. They are referring to the fact that if you turn yourself around in a circle, you're going 90, 180, 270, 360 degrees to be a full turn. Here's a quick question for you. What would you call it if you did 2 full turns of a circle in midair? What would a skateboarder call that? Or a snowboarder, or maybe a gymnast? They would call this a full 720. So that's when you come up into the air and you spin around once, and then you keep spinning around again before you touch back down on the ground. And the reason they call it a 720 for doing 2 full turns is this reason. 360 plus 360 is 720. 720 degrees is 2 full turns. This is probably maybe a little more information that you need to know right now, because all I'm really expecting you to do is to identify whether an angle is, first of all, acute, or maybe it's a right angle, maybe it's obtuse, maybe it's a straight angle, or maybe it is a reflex angle. So check this out. Angle A, if we measure with what we know is already a right angle, the corner of a piece of paper, then we can see clearly that, can you see that behind the paper? You can still see the pen mark. You can see that this right angle is bigger than that small angle A. So this is an acute angle. This angle is acute. Angle B, let's check this one out. So if we bring in our piece of paper and we measure it, we can see, oh wow, that's a little bit bigger. That's why angle B is obtuse. Now, again, this is not a perfect drawing, but I drew it well enough that if we look at angle B, here's angle B, we measure it with our paper, we can see visibly using our right angle Starbucks receipt, we can see with that corner piece of paper that it is bigger. Angle B is bigger than a right angle. And angle A, just like we saw over here, angle A is smaller. You see how the line, you can see it from behind this translucent paper. Angle A is acute, smaller than a right angle. That means that angle A has less than 90 degrees in it. Angle B has more than 90 degrees. Measuring these angles and telling me how many degrees exactly they have That's a whole topic for a whole nother video. We're not going to get into that quite yet. But this is how we define the right angle, the acute angle, and the obtuse angle. In fact, we can use the lines on the paper really quick. I'm drawing this line along this red line on the piece of paper, and another line that intersects. Let's make them two rays. So there's this ray and this ray. They intersect at this point, and they make something called a right angle. You see how I have a little curved line here on the obtuse angle and a square, tiny square right here? This is how we indicate and make it clear to anyone looking at our angles that this is just a normal angle. This is just a normal angle, but this one is special. This is a special angle because it's one of these quarters of a circle. It's one of these 90-degree right angles. Whenever you say something is a right angle, you're talking about this, where you can measure with your receipt, and it's going to be exactly a right angle, matching perfectly. Let's talk about a few more types of angles. Let's say you have a ray that goes off that way, and then you have another ray coming from the same point going in the opposite direction, and you say, okay, what is the measurement of that angle? The answer is that the measurement of that angle is 180 degrees, and we call this a straight angle. We call it straight a straight angle because if we're starting at this point with the ray that goes off infinitely in that direction, and we turn the ruler 180 degrees around, then it's pointing straight back in the other direction. So it becomes a straight angle. And yeah, interestingly enough, it doesn't it doesn't matter whether you call it a straight angle like that or a straight angle like that. It's the same thing. These two things are equal to each other. That is a straight angle, and I can prove it, because remember when we cut our circle in half the first time, we had half of a circle, which makes a straight line. Two 90-degree angles put together, they make 180 degrees, and they make a straight angle. Those pictures are saying exactly the same thing. Alrighty, last little topic, reflex angles. So sure, you might have an angle that looks like this, but if you draw it to indicate that this is what you're measuring, then this is called a reflex angle, because you have stretched your angle out even more back than a straight angle would go. Like going straight up to here would be a 180 degree straight angle. But if you stretch back, it's like a reflex. You're stretching your hand, reflexing your hand all the way back to here. Anything past what would be a straight angle is actually a reflex angle. So let's draw more reflex angles. That's a reflex angle. That's a reflex angle. Even this one, where it looks like a right angle, but I indicate this to show that it's reflexing all the way back. This is a reflex angle. All of these are reflex angles. If we draw an angle like this, but indicate this is what we're measuring, this is an acute angle. If we draw an angle like this, and we indicate that is what we're measuring, this is an obtuse angle. Sorry, I don't have very straight lines today. If we draw an angle like this, sorry, you're going to have to believe me that this is a right angle. Look, it looks almost the same, but we're indicating that this portion is what we're measuring, to go from here all the way to here, how it rotates, like a door on a hinge. This is opening the door really wide open. This is opening the door just a crack. That's an acute angle. Opening the door really wide open. This is an obtuse angle. Opening the door exactly so the door frame is facing straight out is a right angle. All of these are reflex angles. This one is acute. This one is obtuse. This one is right. So, I hope that you have learned the definitions of a right angle, an obtuse, and an acute angle. I hope this is helpful to you. Thank you.